Hi, in this video we'll be solving quadratic word problem number 18. So the length of a rectangle is 5 centimeters more than its width. Its diagonal is 25 centimeters. Find its dimensions. In this word problem it's quite reasonable to sketch the situation. And as we know, we are talking about the rectangle, which is denoted like A, B, C, and D. Line segment AB is called A, and line segment BC is called side B. And it's important to realize that the diagonal is the line segment which is connecting vertices A and C, and it's usually denoted by letter E. As you can see, and as this is the rectangle, the angle by vertex B is right angle. So to calculate the dimensions of the rectangle, we'll be using Pythagoras theorem, which says E squared equals A squared plus B squared. We have to use another information, and this information is that the length of a rectangle is 5 centimeters more than its width. In this case, it would mean that side A is equal to B plus 5. And now we have like two equations with two unknown, because E squared is 25 squared equals, and instead of A squared we will write B plus 5 squared plus B squared. And this is like very simple quadratic equation. Let me do one step. 625 equals B squared plus 10B plus 25 plus B squared. We will simplify, and I will take away 625, so 0 is equal to 2 times B squared plus 10B plus, not plus but minus 600. I was trying to be very quick. And if you have a look, I like to rewrite my equation so that I have the quadratic expression on the left side of the equation. So 2b squared plus 10b take away 600 equals 0. And if you have a look at this equation, it can be simplified. How? Yes, there is a common factor 2, so we will multiply our equation by 1 over 2, and it will be simpler, which means b squared plus 5b take away 300 equals 0. In this case, I am a little bit lazy to to solve it by factorization. By factorizing, so I'll be using quadratic formula. So discriminant equals b squared, take away for a c, which in this case is 25, minus 4 times 1 times negative 300, which is 1225. Now let's calculate b1, b2 by the formula. So it's negative b plus minus square root of discriminant divided by 2a. So my numbers are minus 5 plus minus square root of 1225 divided by 2. And now our challenge is to find the square root of 1225. So how do we do? I was explaining that on Friday during my lesson, and I will try to do it again. So we are looking for simple numbers. If we square them, one of the squares is lower than the number I'm looking for squared. So I'm looking for the number Vj square, and is lower than the square of the number which is the solution of my equation. So in this case the simple number is 30, because 30 squared is 900, and the second number, which is above my number, is 40, because 40 squares is 1600. So let me put it this way. And I'm really I hope everybody now is clear and understands that my number must be between 30 and 40. And from the knowledge that if we square any number, it must be 5 at the end of my number. There comes only one possibility, because only 5 squared gives me 5 as the last digit in the product. So there is only one number which is probably the correct number, and it's really number 35. So I'll try to square 35. 5 times 5 is 25. Sorry, 25, number 2, so it's 15, 16, 17, it's again 15, and 1, so it's 10, 5, 2, 1 remainder, so 1 plus 1 is 2, and my result UP is 1225. So the roots of my quadratic equation B1 equals negative 5 minus 35 divided by 2, and B2 will be minus 5 plus 32 divided by 2. In this case, B1 equals negative 20 and B2 equals 15, because 30 over 2 is 15. As we already know, A is equal to B plus 5. So as this is negative number, it's not a nice number, because we usually don't provide the lengths in negative numbers. So we take only the second root, which is 15 centimeters, and we calculate A, which is 15 plus 5, and it is 20. Okay, so the conclusion, or the representation of the result: side A is equal 20 centimeters and side B is equal 15 centimeters, which fits to the assignment, because A is 5 centimeters longer than B. And if you want to, you can check these two numbers about this Pythagoras theorem, and you will see that our result is correct. Thanks for watching and enjoy math.